Hi everybody. So in this video, I'm going to show you how to transform a cubic equation by transforming its roots. So we have this cubic equation and we're told that its roots are alpha, beta and gamma. And we've been asked to find the equation with integer coefficients that have roots alpha minus 1, beta minus 1 and gamma minus 1. So I showed you in the previous video on transforming the roots of quadratic equations how we can do this graphically. But that would be much more complicated with a cubic. So we're going to use the algebraic method. Now we know alpha, beta and gamma come from this equation involving x. So if we say then, let a different variable, w, equal x minus 1, then we can say that x will equal w plus 1. Then all we do is we substitute this expression for x back into our original equation. So we have two lots of x cubed, or w plus 1 cubed, plus 11 lots of w plus 1 squared, minus w plus 1 minus 30, and this will equal 0. We can use the binomial expansion to expand this out, so we've got two lots of w cubed plus 3w squared plus 3w plus 1 plus 11, and we'll expand that with w plus 1 squared, so w squared plus 2w plus 1. We'll expand out this bracket as a negative w minus 1, and then minus that 30, and this will equal 0. We can expand that with brackets and tidy up with constants. So we've got 2w cubed plus 6w squared plus 6w plus 2. We'll expand out this 11, so 11w squared plus 22w plus the 11 minus the w, and then minus this 31. This will equal 0. Now I'm going to highlight the like terms. We've got the w squared terms, the w terms, and the constants. If we tidy this up, we've got 2w cubed, we've got the 17w squared, we've got 6, 28, 27w, and then we've got the 2, 13, take away 31, which gives us negative 18, and this will equal 0. So this is our transformed equation involving w, and we can check that this works. If we find the roots alpha, beta and gamma from this cubic using our calculator, then we'll go into equation solver. We want polynomial, we want the third degree, then we'll enter the coefficient of x cubed as 2, then 11, negative 1, and negative 30. So you can see our original equation has a root alpha at 1.5, beta at negative 2, and gamma at negative 5. And then we can compare these roots to the roots of our transformed equation. So we'll enter in these coefficients. We've got 2, 17, 27, and negative 18. So you can see we've got roots of alpha minus 1 is 1/2, which is 1.5 take away 1. Beta minus 1, negative 3. And for gamma minus 1, negative 6. Okay? So this is just to show you that by creating a transformed equation using these roots, which is this, we do get the roots that we were expecting. So perhaps you want to transform this equation using these roots. You can pause the video, and when you come back, we'll go through the worked solution. If we let t equal 3x now, then x will equal t over 3. And we substitute this t over 3 back into our original equation. So we get 2 lots of t over 3 cubed plus 11 lots of t over 3 squared minus t over 3 minus 30. We can expand that by brackets, so 2t cubed over 27 plus 11t squared over 9 minus t over 3 minus 30. And then we multiply everything by 27. We get 2t cubed plus 33t squared minus 9t minus 810. And this will equal 0. And just for fun, we can work out these roots: 3 alpha, 3 beta, and 3 gamma. So 2t cubed, 33t squared, minus 9t, minus 810. And we get 3 alpha is 4.5, 3 beta is negative 6, and 3 gamma is negative 15. And when you compare these to the original equation, they are what we would expect them to be. Okay?